Finding g of z doesn't look very promising, especially since we ultimately want to find g of z, which means applying f to z 4 times. Looking back at the problem statement, we see that g of z is equal to z for all z, and an Amy hack in this situation is to try a z that is easy and convenient. We'll use z equals 0. We'll start with f of 0. This is equal to a over b, which is much simpler. Let's apply f again. We'll multiply by the denominator to simplify. This isn't too bad. Let's try it a third time. This expression is getting pretty complicated. I don't want to have to take f of this fraction again. So let's see if we can go backwards and start with a value of z such that f of z is equal to 0. Then we can continue from this step, and this will be our second step. So we want this expression to be equal to 0, which we have when z is equal to negative a. So we can start with f of negative a is equal to 0. When we apply f a second time, we get a over b. Then applying f a third time, we get this next fraction, and then we apply it our fourth time. Since we're looking for g of z is equal to z, and again this is true for all z, we can look for g of negative a is equal to negative a, and that's what we have here. So we'll set this expression equal to negative a. We'll simplify the left-hand side and multiply both sides by the denominator and expand. Since the magnitude of a is 1, we know that a is not 0, so let's divide by a. We're trying to find the magnitude of b. Let's put all the b terms on one side. I notice that we have a common factor here. If I factor out b squared from these first two terms, I get b plus 1. And factoring out 2a from these two terms also gives me b plus 1. So I'll factor b plus 1 from all three of these terms. This is true when b is equal to negative 1. This gives us a magnitude of 1. Over here, this factor has to be 0. So b squared is minus 2a minus 1. From the problem statement, a is a complex number with a magnitude of 1. This puts a on the unit circle. Negative 2a has a radius of 2, and negative 2a minus 1 shifts this circle to the left by 1 unit. When we draw this circle, it looks like this. So we're trying to find the maximum and minimum values of b when it's on this circle of radius 2. This magnitude of b is the distance from the origin. In order to maximize it, we need to maximize the magnitude of b squared. The point on this circle with the greatest distance from the origin is this point here, where b squared is equal to negative 3. This means b is plus or minus I root 3. These are 2 points on the imaginary axis, and the magnitude of both of those points is root 3. To minimize the magnitude of b, we're going to minimize the distance from a point on this circle from the origin. We get that over here, where b is equal to 1, and the magnitude of b is equal to 1, which is what we had earlier. So the difference between the maximum and the minimum magnitudes of b is root 3 minus 1. That is option C. If you'd like me to solve any other contest problems, please leave them in the comments.